Oh, boy. Okay, so
Sorry about that. So the first one, you gotta find the proportion of those surveyed who have been in an automobile accident in the last 5 years. So the way you do that, 684 divided by 1,000, and it's 0.684. Does that make does that make sense?
you keep on cutting out. What are you trying to ask?
So does it make sense how to find the proportion of the people who got in an accident in the last 5 years?
Yeah, the 600. Okay, so yeah, it did make sense. The 600 so on divided by the 1,000. Uh, so B, check the requirements in constricting a confidence level for this data. Um, so let's see. 684.
Okay, so where are you at? I'm sorry. So we did the proportion for number one.
So we're on B.
Oh, you're on B. Okay, 1A, B.
Oh.
So the requirements are met because the sample size is greater than 5.
Um,
So determine the margin of error for a 95% confidence interval based on these data.
does it say it in this? Okay, I believe we have to calculate that on our own. Um, so let's see.
So M equals the z-score, or the test statistic, I guess, which in this case would be 1.96.
So let's see. We know the p hat, but what's p?
What was that?
We know p hat, but what's p?
P is. Oh yeah, that's right. P hat. Um, let me see. So first we gotta find P tilde.
P tilde?
Yeah, the P with the wavy line above it.
Okay, so that's the x plus 2 divided by n plus 4. So let's see.
So X is gonna be.
So x divided by n.
Alrighty. Gives us 686 over 1010.
I got 0.6792.
Okay. Now, where do we find the? What are we doing? What we need to find the margin of error. Oh,
Yeah.
right. Do you have the answer key open? Hello?
I'm still calculating it all, but yeah, I have it open. Um,
You could do this.
okay, so I believe I got it right. I mean, because it says it's 0.0288, and I got an answer of 0.02878. So yeah, basically 0.0288. Mm,
Oh, so you got point oh two nine. So point
so
oh two eight eight.
0.029. But well, more adequately, it's 0.0288
Okay.
is what it says on the answer key, and I got 0.02878. So yeah, I believe that I did it right.
So how did you end up doing it?
Um,
Yeah.
uh,
you plug in 0.679 in the place of P? Sorry?
But
Sorry,
I don't see where it says.
I didn't catch what you said. You cut out. But just answer me this? Did you do 0.679 in the place of P?
7.9. Yeah, 0.6792.
Okay, sounds good. Now, I use 0.680, so it's the same, pretty much, almost. So anyways, so now that we have the margin of error, uh, okay. Now, let's see. Construct and interpret the 95% confidence interval for the proportion of those who have.
See if I can reach her.
What was that?
Let me try calling Veronica, see if I can reach her.
She's texted me. She said she's coming.
Oh, okay then.
But I'll email her one more time because I asked her if she was online. She said no. She must have forgot or something, which seems weird. Cause, anyways, so
oh, there she is.
So now what we do for the. Did Veronica make it ever?
Hold on.
Oh, Veronica! Yay!
Hello?
Hey!
Hey. Sorry, my computer's not working. I'm using my phone right now.
Oh.
Oh.
Yeah, I thought it was for that reason that you said that last go round it crashed or something.
Yeah.
Okay. So we're doing the homework here. Is there a way you can get that open at all, or?
I'm trying.
Oh, okay.
I just got the other computer, so I'm gonna see if I can get that one going faster.
Okay.
Because I guess mine's still not working. I thought it'd work today.
No worries. So I got to study for a test tomorrow morning. So I kind of have to hurry through this so I
Okay.
can get studying in.
Just go ahead and start, and if I can get in, I'll get in.
Okay. Sorry.
Did you?
But we've done a few. We've gone ahead and done a few.
Mhm.
So we'll just keep going and then catch you up when you get it open. Okay?
Okay. Thank you. Sorry.
No worries. No worries. Okay. So.
We're on D.
D.
Construct and interpret the 95% confidence interval for the proportion of those who have been involved in an automobile accident in the last 5 years. It
So
said 0.6504 and 0.708, and when I put it into the program, in mind that it's 686 and 1010, I got the same thing. If you put in the previous answers, you get something just slightly different, like 0.709. So those are the values we are using.
okay.
8, how many college students should use survey? If you want a 95% confidence interval with a margin error of no more than 0.015. So for that, we would be using the number one. That would be 0.16, 1.6 or 96 divided by 2 times 0.015, and then square that, and I did not get what the thing said. Says it is.
Maybe maybe instead of, because there's two ways to do it, right? If you have a proportion estimate already, you can plug in
Oh,
uh,
right.
multiply it by p times.
That's right, because wait, did we get P?
Yeah, we have p. So so p is just proportion. So p hat and p can be
Divided
just proportion. So you
by
just do
5 whole square. So let's see, that's 0.073. Okay, and let's see, what's P again?
0.680. Well, 0.679, whatever you want to do. Like, I would just go with 0.680. Then you do. Okay, so. Times.
Okay. And I still did not get the right answer.
What's the answer? I can't see it on mine.
Um, it says the answer is 4268.44, which is rounded off to 4269.
Huh.
Let me try. Maybe. Oh, wait, hold up. Hmm. Divided by- Yeah, I must be doing something wrong.
Hmm.
Hmm.
Can you put the screen share so I can look at it?
Let me try something. I might have put something wrong in the calculator.
Here, I'll do it.
Okay, here we go. Yeah. So we used the second equation if prior estimate is not available, which it's not available in this one. It does not say um, anything about any previous polls. It just, I mean, we have p hat and we can use the +4, but it's not available. So I got 0.268.44 repeat or 4 repeating. So yeah, that's the answer. So
Four two
that,
six 8.4.
huh?
Okay, so you're right. Use the first one. So, Veronica, did you want to see the question?
Yes, please.
Okay, let's see if I can pull it up. Can you guys see it? Aha.
Okay.
You see it?
Yeah, which one are you guys on now?
We're on number 2. So if you want, I'll just keep that open, Veronica, and you
Yes.
can.
Yes, please. I'm almost there, and I don't know, this thing is restarting itself.
Okay. Sounds good. Glad I'm able to help there. So, hypothesis test. Now you're interested in testing the claim that over 60% of all students have been in a car accident within the last 5 years. Use the same information as above and use a level of significance of alpha equals 0.05. State the
So,
null. I'm sorry.
oh, so I was about to say this time we do have p.
Right, because 60%.
Mm.
That's 0.60, isn't it?
Yep,
Yeah.
0.60. So the null hypothesis would be 0.60. Equals 0.60. Alternative hypothesis would be the proportion is greater than 0.60, right?
Mm.
Yeah.
Because you're testing a claim that over. Wait. Yeah, over 60%. Okay. So compute the test statistic now.
Oh, so
To
let's
be
see.
test statistic.
If we want to write it by hand, that's included in the last lesson. But let's see how well it does it in. Hold up. Hmm.
So
So this go around, we have to. I would guess we have to use Well, question is, do we use the +4 one or do we use the normal?
um, let's see. So you can just use um. So what's p hat in this case? It would be
Well, going back, that's what I'm trying to. That's why I'm asking. I mean, either it's the .6799 or the 0.6792. For what reason do we use the 4? Plus 4?
We use it for, oh my gosh, for the confidence. We use it only for the confidence interval.
So we're probably just going to use 0.6799.
Oh yeah, that's right. Okay. So 0.680. It'll be, let's see, minus 0.60 all over square root of 0.680 times 1 minus 6.80.
Okay, so I got 5.172. And it says it's 5.173.
Okay. So, and did you do the thing? So, what did you put for the? Where you are? Point six. So what did you get for it?
I got 5.172.
5.172?
5.172.
It must have been different, but because I got a little bit higher.
What'd you get?
So did you put? I got 5.439.
5.4?
So did you put? Yeah, 5.439. So did you put 0.680 minus 0.60 all over square root of 0.680 all over?
Oh, so basically I put 0.6799 minus 0.6 divided by the square root of 0.6 parentheses 1 minus 0.6 divided by 1006. And that's the answer I got, is 5.172. Ah, crap. Hey. Oh, so while he's gone, I'll discuss what we talked about with the project. So I was saying basically either the Starburst, the cereal, or the the Oreo. But we both believe that the Starburst one is probably the easiest one for all of us to do since we're in different states. Well, you are in a different state.
Okay.
The Oreo one would have been interesting, but you know, we don't have a scale. I
Okay.
mean, me and Kevin has access to a scale, but you don't. Or I would believe you don't.
A scale?
Like, for example, we could probably go to the chemistry room and get the teacher's permission to use a scale that's used for grams. That's not exactly common for people to have.
Oh, yeah, no.
We talk about bathroom scales that weigh in pounds.
Yeah.
So yeah, I mean, we think we're going to do the Starburst one, and that we're going to do two. We're going to each buy 2 packets of packs of Starburst. Of course, one thing we should note is make sure we all get the same sized bags. Let's see. Okay, so
So I did,
Kevin's back.
so I got, yeah, I'm back. Sorry. So I got 5.179.
Well, what'd you get?
Is that the right answer? 5.179.
So you're a little bit too high. What do you put in?
What's the answer you say?
Oh, sorry, you said point. You said 179.
Yeah, 5.179. What does the answer key say?
5.173. I got 5.17. The
All right,
answer
well,
I put in I put in 0.6799 minus zero point 0.6 divided by the square root of zero point 0.6 parentheses 1 minus zero point 0.6 divided by 1006. What'd
that's
you?
basically what I did. I just rounded up. So I did 0.680 instead of 0.6799. So it shouldn't be that big a deal. So maybe we used the wrong test statistic, but
Well, I
uh,
mean, again, we have found that he made mistakes before.
yeah, that's true. Cool. So let's go to the next one. You want me to do a screen share again, Veronica?
No, you know what? I just got it pulled up.
Oh, great.
Okay, so determine p-value based on test statistic. Sketch your p-value on the normal distribution curve with the with the test statistic labeled. Um, so we're going for. Oof, hopefully that's the right answer. Ah, good. So I got the answer of 1.158 to the negative 7th power. This has 1.15 to the negative 7th power. So it's a bit different. Let me try 7. Okay. And then I changed it to 5.173. That makes more sense, according to how he's done it, I guess. Either way, it's the same result. We reject the null hypothesis, and we're pretty much done.
That's weird. I don't get it.
Well, what we got the Z score 5.17. Well, I got 5.172, but he's using 3. So it makes more sense to put in 5.173 according to how he's done it. But yeah, I put in the Z-score. I highlighted the area above, or the greater than, and then I got a where was it? I got
Oh,
a
I got it.
okay, good.
Yeah, I got it.
So I got a p-value of 1.151
Yeah.
to the 7th power. If you use the same one I've got earlier, the 2, then it would be 1.158.
Yeah.
So since it's times 10 to the negative 7th, that makes it really close to 0.
Mhm.
So that means that means it's such a small number we reject the null hypothesis. So that means we have sufficient evidence to conclude that the true proportion of students that have been in the car accident within the last 5 years is greater than 0.60. So, awesome.
So since you have stuff to do, let's go ahead and start the quiz.
Sweet.
Okay, and we have 15 questions to
Doesn't cut
answer.
out anymore.
Let me know when you guys are there.
I'm there.
Okay. Number 3, I believe it's the third one, just P.
Yeah.
Let's see. For question 4 and 5, suppose n equals 20 and p equals 1/4. The requirements for constructing a confidence interval satisfied. So what was that again? If it's satisfied, oh, okay, that it's greater than or equal to 10. So what was it? So first we need to get p hat. 5 divided by 20 equals 0.0125. And let's see, p hat times the number.
I'm sorry, number 3, you guys said P?
For number 3, we said P. Yeah, the third one.
Okay.
Mm-hmm. Then for number 4, it's true. Because yeah, it's true because the confidence interval, the only parameter is that the sample size has to be greater than 5 or equal to 5. So sample size is there.
Wait, hold up.
The hypothesis.
It says here that the confidence intervals are valid whenever n p hat is greater than or equal to 10, and
That's the hypothesis test.
is it where does it say the where in the lesson does it say the whole confidence interval thing? If it's
I don't know for sure. I watched the videos instead this time. So let me.
okay, here it is. Like other procedures, there is a requirement that must be checked in order to So on, the +4 confidence intervals are valid whenever the total sample size is at least 5. Hmm. Okay, yeah.
So that's for the
Okay.
confidence interval, right? So, but you're right for the other one, and in that case the answer would be false because I just tested it while I was waiting to log back on, and if you multiply 20 times 0.25, you get 5, and that's not greater than 10, so it doesn't work.
Okay, so 4 is true, 5 is false.
Yep.
Number 6, a study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for the first-degree murder was taken. Of these, 45 of the defendants were found guilty. Use this information for 6 through 9. Find P, whatever that squiggly thing is, the +4 estimator of the proportion of first-degree murder defendants who are guilty in this state. Okay, so that would be,
That's the x plus 2 divided by the n plus 4.
yeah.
Yep.
Okay, so let's see. It's 47 divided
I mean
by
45. Oh, never mind.
64. So I got 0.734.
Yep.
Yeah.
Then the next one would be just 0.75, right? P hat.
Um, oh, okay. What'd you get?
Would it be 0.75?
Yeah.
You just divide
Yeah.
45 by 60? Okay.
Um, so let's see.
Create a 95% confidence interval for the true proportion of first-degree murder trials in the state where the verdict is guilty.
So that would be the second one, right?
Sure. How'd you find that out?
Um, I used I input that into the program.
Oh, okay.
45 for X and 60 for N, because it didn't say we were using the. It said we were using the traditional estimator of the proportion, not the hypothesis test.
Mhm. Okay.
Oh wait, no, sorry, that's the 7. Create a interval for the true proportion of the first. Yeah, it doesn't say that we're doing the hypothesis test.
Cool.
Is that what you got?
I don't know. I would have to calculate it out. So if you got the second one, I believe you.
Okay. I mean, again, like as I told you in the beginning, I don't entirely understand, but I believe that's correct.
All right. Well, I can work it out real quick.
Yeah,
You want to go? You can go to the next one if you want, or something.
yeah, I'm looking at that now. If you increase the simple.
I got the second one too.
Okay.
It's N again. So, oh man. Oh. Let's see. Um. Divided by it's N was 60, right? Oh, that's weird. I got the third one actually. When I calculated it out, I got the third one.
You got the third one. What'd you put in the X and N?
So what I did was I did P tilde, which we decided was 734 or 0.734, right? And then I plugged into the formula P tilde plus or minus Z, which was 1.96 times square root of P tilde, so 0.734.
Well, to skip all that, the difference that you put in is you put in P tilde. I just put in what was it? Is that P or P hat? I put in the 45 and the 60 because it doesn't say anything about the hypothesis test.
Well, I watched in the videos that the confidence interval you have to do this tilde formula.
Whose dogs are that?
Oh, sorry. I think they're mine. Actually, no, I think it's my neighbors. Sorry.
Oh. Well, I mean, what do you think, Veronica? Do you think we're going to use 45 and 60, or are we going to use the P tilde, like the +4?
Well, if you look on the lesson,
Mm-hmm.
if you're trying to find the interval, the confidence level of 95, they do the one that Kevin's saying. They do that equation. They use a P tilde.
Oh, so do we always use P tilde when it comes to the confidence intervals?
I don't know if it's in every case.
Oh, well,
But
I mean, as we scroll down, actually, it shows like where we're using P hat as well, so we should try to determine which we use for this.
Oh, yeah, that's true. Let's see. Okay, let me look at that question.
For the true proportion, let's see. It says for the true proportion of the first degree murder trial. So. Let's see.
Oh, wait, hold on. Let me just go back past the answer.
I think when we use the p hat, it's when it's one proportion. But no, it is p. What was the other one you said? P tilde. It is that.
Tilde?
If you read, it says the upper bound for 95% confidence level for a true proportion. P is that equation, the p tilde.
It says down here, like when it's showing the equations for p hat, So the lower bound for 45% confidence interval for the true population P is, and it shows the equation using P hat.
Does it say C? Oh, okay. Oh, here we go. On the lesson it says, so on 2.2.1 it says we use the symbol p hat to denote the traditional estimator of p and p tilde. Okay, I'm sorry, that's the wrong spot. Ta-da. Okay. So that's one place. Okay. Okay, here we go. About 1/4 of the way down, under 2.2.1, it says remember that for a 95% confidence interval, z equals 1.96. So the lower bound for the 95% confidence interval for the true proportion p is, and it shows the tilde formula. So I think p hat is used for the sample proportion, and then p tilde is used for the true proportion. I'm pretty sure it's this. I'm pretty sure it's p tilde because that's what I wrote down from the video from the notes.
Oh, you looked at the video for notes?
Yeah, I did. I did this time because one of my friends suggested it, and I liked it. I liked it a lot, actually.
Yeah, I never
But
really knows.
yeah, the videos give the same material, and sometimes they're easier to watch than to read. But anyways, so I'm pretty sure it's that. Pretty sure it's the third one. But if you want, we can check it. We'll submit it. I'll submit it first if you want, and then we can know for sure whether it's right or wrong. Alright, cool. So if you increase the sample size from 60 to 80, what do you expect will happen to the width of the confidence interval? So, pretty sure. I'm pretty sure it would increase.
Wait, hold up. 9 might have part of the answer because it's talking about increasing the sample size from 60 to 80. 60 is the original one.
Oh. Okay, hang on. I guess we can.
It actually decreases.
It decreases, huh?
Yeah.
Depends on how we. Well, let me take a look. I put decrease before as well, but I'm calculating the new values.
Actually, hang on. Oh, wait. No, you're right. Yeah, you're exactly right. It would decrease.
Yeah, it decreases.
Yeah.
And plus, it makes sense that it would decrease anyways. Because I believe the larger the size, the smaller the confidence interval.
Yeah. Yeah, it's different with sample size. Okay, cool. So number 10, to conduct a hypothesis test for one proportion, 2 requirements must be met. Suppose.
That one's 20.
Okay.
You guys should go ahead and calculate that.
Yeah, because if 20 times 0.5, it's 10 right there. Yeah, 20 is right.
Yeah.
To conduct a hypothesis test for one proportion, okay, 1/10. So, okay, so gotta be 100 probably. Yeah, it's 100.
Just a sec.
Oops, excuse me.
Yeah. Okay, so yeah, 11 is 100. Okay, number 12 for the questions 12 through 17, use the following information for the water quality study and the reading. About 60% of the macro invertebrate water quality indicators have historically been associated with good health. The researchers suspect that water quality in the area has decreased. They conduct a hypothesis test using significance level 0.05 with the following hypothesis is null hypothesis p equals 0.6. Alternative hypothesis p is less than 0.6. They collect new data this time. N equals 80 and x equals 38 indicate good health. The conditions for conducting the hypothesis test are satisfied, true or false.
I'm pretty sure it's true. So what
Yeah.
I did, I pushed 80 times 0.6. Is that the right thing to do? Because it's you're supposed to do n times p, so it's p.6.
Are we supposed to do the confidence interval after we converted, like do the x plus 2 and n plus 4, or
That's only with the confidence interval.
okay,
The hypothesis test doesn't. You don't need to do that one.
okay. So you believe it's true?
I think it's true. But am I using the right one? Like, is it n times? Because I know it's n times p, and that has to be greater than 10. So I did 80 times 0.6. Is 0.6 the right one to use?
Yeah,
9.6.
as long as it's greater than 10. Yeah, it is.
Well, we're supposed to use p hat for like n parentheses 1 minus p hat or the other requirement. So let's see. That would be 38 divided by 80. Okay, and then we use let's see, 80 1 minus 0.75. Okay, so that equals 42. And that's greater than 10.
Okay. Sounds like it's true then.
Yeah.
So you said what is p hat, and it's going to be, let's see.
P hat is 0.475.
Find the test statistic. Z equals
0.475 minus 0.6 equals divided by the square root of 0.6 minus 0.6 divided by 80. I got negative 2.28 2. Is that what you guys got?
I got 2.
Huh?
That's what I got as well.
Oh, the negative?
Yeah, I got negative 2.282.
Negative 2.282.
Yeah, I got that too.
And we're trying to see if it's less than zero point 0.6. So we shade the lower tail.
I got
So I got
0.011.
0.011, yeah.
So we reject the null, right?
Yep.
Yes. And there is sufficient evidence to include the water. There's sufficient evidence to conclude that the water quality in the area has decreased.
Yep. I think that's the one.
Yeah.
All right.
Cool. Well, let me see. That way you can know if a number, let's see, what number was it? Number 8 was right or wrong.
All right.
So, I got 100%, so it was right.
Okay, so
it's
8
the third
is
choice. Yeah, it's the third choice.
Yeah, so when it's true, we do the what was that? What is it called? P what?
plus 4. Tilde.
P hat or P,
P tilde.
P tilde?
Yeah, that one. P tilde.
Oops. Yeah, that's
Yeah.
name.
But it's a confidence interval.
My bad. That's the name of one of my old dog. Oh wait, no, that's the name of one of the puppies of one of my dog. Is Tildy. Yeah. Okay, we could probably just do the homework on our own time or tomorrow, since Kevin has to get to his studying. And
Thank you, I appreciate that. We should meet probably on Saturday just to wrap up the project.
let me take a quick look at.
Can we meet tomorrow for the project? Because I'm not going to be around on Saturday.
Yeah.
Oh, yeah, we can meet tomorrow. Tomorrow actually might be better for me, too.
So let me take a look at the final project overview. So it's due Saturday at 11:55 p.m. So, yeah.
So why don't we do it tomorrow? Because I don't have time on Saturday really either. I have state conference and a bunch of other stuff.
Mhm.
So we can do it on tomorrow.
Is state conference due? I mean, on?
My state conference is on Saturday and on Sunday. Because there's a Saturday session as well.
I think he froze.
Oh, he froze. Okay. I was like, you don't believe me?